Okay, so today we're working on 4-5. It is the transformations of a quadratic function. So several things here. We've already done the factoring, the quadratic formula, and complete the square. And I kept talking to you about the importance of that because it showed us where the parabola crosses the x-axis. And at that point, you didn't really know what a parabola was, and I was drawing you pictures to show you. Well, now we're at that point where we know what a parabola is. And the way a parabola is made is x squared. You take your x values. Here are your x values here. If you take 1, here's 1 here, and you square it, okay, 1 squared is 1. Okay, so you have x is 1, y is 1. 2 squared is 4. So here's x is 2. Here's your x column. X is 2. 1, 2, 3, 4. Now if you go the other direction, -1 squared, remember a negative times a negative is still a positive, is a 1. -2 squared is 4. You can keep going. 3 squared is 9. So 3 squared would be up here, 9. Okay, you can keep going. Just because this table stops doesn't mean the parabola stops. These arrows mean that the parabola goes on in both directions. Okay, several parts to a parabola. Here, where the parabola changes directions, it's going down, 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 and the very moment that it changes and goes up, 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 that's the vertex. The vertex is 0, 0. And this is the parent function. This is the plain Jane parent function. If you think a minute back to our good old friend, the v, the absolute value, we talked about the parent function. And that was the vertex there. So the parabola and the absolute value are very, very similar. Except this is more curvy and has a U shape, whereas the absolute value has a V shape. The axis of symmetry is an imaginary line that runs, it splits the parabola in half. It goes through the vertex. The axis of symmetry is the same as the x of the vertex. Okay? It's the x of the vertex. You have your x and your y. Our domain, it's been a little while since we've done domain and range. Our domain is how wide the graph is. It's our x's. Okay, so it might be kind of hard for you to take notes right now, but you could probably write this down right here. Okay, maybe hard for you to write the graph down. You could draw you just a little bitty sketch of it and try to get a little bit of it down. It would probably be a good idea if you can sketch yourself the parent function of the graph. Okay, if you need to pause the video, that would be appropriate probably now to try to get caught up on some of this drawing. Okay, so the domain is how wide is the graph. We talked about how this is going to go up, up, up forever, but it's also getting wider. Okay, you can see right here it's getting wider and wider and wider. So eventually it's going to go forever in this direction. It's going to go forever over in this direction. So the domain is all real numbers. Okay, or if you wrote it in interval notation, from -infinity to +infinity. I'm going to change colors here. I don't think that orange is great. Now the range, it doesn't go forever and ever up and down. Remember, the range is how tall the graph is. Okay, that's your y's. It starts, and remember, range is from bottom to top. So on the bottom, it starts at 0, and it's equal to 0, so we put a bracket. Then it goes up, up, up to infinity. So it starts at 0, it's equal to 0 because that vertex is on the 0 for the y, and it goes up, up, up forever and ever and ever to infinity. That's interval notation. Here's inequality notation. Your y is greater than or equal to 0. Okay, so now those are the basics of the parent function. Let's talk about the h and the k. Okay? Your good friend h and k. Let me write this right here. Y equals x minus h squared plus k. That's very, very important. That is the equation to a quadratic which forms a parabola. Do you remember our good friends h and our good friend k? Remember, k stands for kangaroo. A kangaroo jumps up and down. So the k makes the graph go up or down. H stands for hippopotamus. A hippopotamus can't jump. So it goes, a hippopotamus only walks right and left. I should have put right and left up, and I'll put left and right. Now remember, if you get confused, who's who? Like down here, you're confused. Who is the H, who is the K? The H is on the inside of the parentheses. And so think of that as like a circle. Think of it like a pond. An hippopotamus likes to hang out in the pond. You're not going to see a kangaroo hanging out in a pond. Okay? So that kind of helps you know where the H and the K are. Okay, so our H is 3 and our K is 7. And remember, H is a liar. So H is 3. Oh, we have it over here. And K is 7. Our A value, so I should have put an A up here. Go back to your equation up here and put an A. Our A value is 5. We're not going to talk much about the A value today. But our vertex, you can just look at an equation and know what the vertex is of it. Here's the vertex. It might be down here, and the parabola might be going like this. We don't know, okay, just yet. We will in a second. We can know that the vertex, it is our H and our K. But our H it's the opposite of the H. So if that's a -3, that's a +3. H is a liar. He's opposite. K tells the truth. So don't write the opposite sign of the K. The axis of symmetry, remember, it's the X of, oops, I wrote that wrong. I don't know what I was thinking. It's the X of the vertex. I even drew an arrow and then I still wrote it wrong. Okay, so let's do another one. So H is going to be -4. It's the opposite. K is going to be 9. It tells the truth. That right there is our vertex. -4, 9. Just like here, 3, 7, 3, 7. Our A value is 1. What is our axis of symmetry right here? It's the X of the vertex. Here's our vertex, okay? Okay, this one doesn't have an H. It's 2x plus 0 squared minus 3. So in here, there was nothing. That's your H and that's your K. So 0, -3, 0, -3. Our A value is 2. The H and the K is going to move it right and left and up and down. We're going to talk about the A value more tomorrow. Okay, and the axis of symmetry is 0. This one doesn't have a K. Our A is -1. Our H is a +7. Remember, it's the opposite of -7. Our K is 0. So from these two right here, 7, 0, that is our vertex. That's the bottommost point, or it could be the topmost point if it's pointing down. And then our axis of symmetry is 7. All right. So let me take a peek at something real quick. Okay, I just want to make sure we weren't doing the A value on this. Make sure I didn't have the wrong worksheet. All right. So okay. So I apologize, guys. I was trying to do two things at once. So they kind of remind us here that K translates the function up and down. They're talking about the K. If it's a positive K, it goes up. If it's a minus K, it goes down. H is on the inside of the parentheses. And if it's a minus H, it goes to the right. Remember, it's the opposite. You would think a minus would go to the left, but that's not true. A minus H goes to the right. A plus H goes to the left. Okay? So those are important little notes. Those are good notes to remember. Okay. So function notation, all you do is you drop the y and you replace it with f of x, and then you don't do the squared part. The squared part tells us that's a quadratic and that that's a parabola. Okay, function notation is kind of silly sometimes to me. When I was a student, it didn't make any sense. Now as a math teacher, it does, but there's not much to it. Don't panic about it. Drop the y and put an f of x. Get rid of the squared. And I might be doing that a little wrong. I don't remember. Okay, vertex, H, K. The vertex is the opposite of the H, but tells the truth of the K. The axis of symmetry is x equals 1. Okay, what is this graph doing? It is moving to the right 1, and it's going up 3. Your H tells you right and left. Your K tells you up and down, but H is a liar. So let's talk about that. Originally, the original parent function is at 0, 0. And then out 1, up 1 on both sides, because 1 squared is 1. And then out 2, 2 squared is 4. So just kind of memorize that. Okay, 0, 0, then out 1 and up 1, and then out 2 and up 4. If you want to get fancy, out 3, 3 squared is 9. Be up here. Out 3, up 9. Okay, so that's the parent function right there. Now this guy has slid around on this graph. So he has slid right 1. So we're going to take the vertex. He's our main anchor point. Right 1 and up 3. 1, 2, 3. I'm going to do it in a whole different color. Right 1 and up 3. 1, 2, 3. Then from that point we just talked about, from the vertex you go out 1 on both sides. So out 1 and up 1, out 1 and up 1. Then back to the vertex, out 2 and up 1, 2, 3, 4. From the vertex, out 2 and up 4. Okay? So again, from the vertex in both directions you go out 1 and up 1, and then out 2 and up 4. All right? And then we're going to connect those dots. So hopefully you can, let me use a different color. Hopefully you can kind of forget that that parent function is there. Okay? But I wanted you to see how it moved. So did our vertex move right 1 and up 3? Yes. Did every other point move right 1 and up 3? Over 1, up 3. So you can kind of check it that way. Okay? The domain of our new green function, the domain is all real numbers, but the range is a little bit different. It's not down here anymore. It's up here. It's from 3, okay? It's from 3 and then everything up. My graph is from 3, everything up. So it's y is greater than or equal to 3. This dot right here, the vertex, is on the 3 line. So it's equal to the 3 line. Okay? Okay, let's do another one. Okay, now this one, this function says, oh, I did do it wrong. I should have put the F in front of it like this. I knew I was doing something wrong. It's been a whole year, guys. Okay. So here's function notation. Okay. Vertex form would be y equals, we're just kind of rewriting this. Now it's going to be y equals x plus 4 squared minus 2. Okay, what's the vertex? Remember, it's the opposite of your h, negative 4, negative 2. The axis of symmetry is the x of the vertex. Here's the vertex. Where's the x? Oh, it's negative 4. Okay? Okay, transformations. Let's talk about what this does. Okay, transformations. It transformed how much? Not to the right. Positive would mean to the right. You could use the vertex, and that's going to tell you the truth. Minus 4 would be to the left. Okay? So left 4, and then a minus 2 would be down 2. So this time, let's don't draw the parent function first. Let's just kind of go for it. It's at 0, 0. From 0, 0, you might want to put a little tiny dot there, okay? It's going to go left 4, and then down 2. But you can't just go like this, guys. I see kids doing that, okay? You're not going to have paper and pencil anyway. But you've got to make it be accurate as possible. So you go over 4, down 2. Let me redraw that. Okay, from this point, in both directions, out to the right and to the left, you're going to go out 1 and then up 1. Out 1, up 1. Okay? Now, go back to the vertex. This time, instead of going out 1, go out 2 and then up 4. Okay? Out 2, because 2 squared is 4. This whole function is the squared function. Okay? So you're squaring all of your x's. Okay? And so then, draw it in. And now it makes a U, not a V. Don't make it look like a V. Not a sharp, pointy corner. Can't talk. Domain is all real numbers. If they ask it for in interval notation, it would look like that. Inequality notation looks like fancy R. Our range, how tall is our graph? If this is an elevator, your y-axis is an elevator, it starts at -2, like in a basement floor of -2, okay? And it goes up, up, up. Okay, basement floor -2, so it's y is greater than or equal to -2. All of the graph, it starts at -2 and is anything bigger. Okay? Okay. Okay, let's write this one. This says to write it in vertex form and function notation. Okay, so here is my vertex. That vertex tells you so much. Okay, it is at point 2, 1. Here's 0, 0. It's at point 2, 1. Remember, when you're naming a point on a coordinate plane, you always name your x first. So that's my h, that's my k. But when we write it, we've got to do the opposite of the h. So -2 squared, but k is good. He's not a liar. Okay? If we wanted to write it in function notation, just drop the y, put an f, don't put a squared, and 1. Okay? This guy, here's 0, 0. So what happened to that vertex? It went to the left 1, okay? And you might even write yourself a note. Left 1 and then down 1, 2, 3, and then down 3. Okay? So y equals x. Okay, going to the left, you would think it would be minus, so it's really plus. And then going down tells the truth. Down 3. Function notation looks like this. It kind of helps us compare it right here. Drop the y in the equals, put an f in place of it, and drop the squared. Okay? Okay, so here's a function, and they say if it's shifted to the right 3, so if it's shifted to the right 3, it's really going to add 3 here to the h, and then up 1. Okay, what's the new equation then? So you get a -1, because -4 plus 3 is 1, plus 2. Okay? Then, hang on just half a second. Okay, and I did this completely wrong, guys, like a goofball. I was even thinking opposite, and probably some of y'all were thinking that too. Right 3 is, you would think it would be plus 3. It's really minus 3. Okay, so I need to fix this. Nope, and nope. Okay, so minus 3, that's going to be -7. Okay, so let's do a better job on this one. My fault. Okay, left 1, and that's all it says. Okay, it's shifted to the left 1. So to the left, you would think it would be minus, so it's really plus. So we do a plus here. It doesn't say anything about up or down, so you're going to leave that. So 8 plus 2. Okay, let's do another one. I think we are going to put some of these on Delta Math, okay? Okay, shifted to the left 2. So this is just the plain Jane parent function. So left 2 would be plus 2, and down 4 would be minus 4. There's your H and your K. Okay, down, left. Okay, and then the last one. Okay, up 3, right 5. Okay, so up 3 is plus 3, right 5 would be minus 5. But you got to do it with the right one. Okay, so minus 8 to the right 5 is minus 5. I can see people putting a plus 3 right here, but the plus 3 goes out here. Okay, 8 minus 5 is 3, and then 3. There was nothing there. 0 plus 3 is 3. Okay? All right. So hopefully that, if you remember your H and K from the absolute value, then you will do okay on this.